This is a conversation with Adrian Popielas and Tony Baltovski from Clearpath Robotics on the TurtleBot 4. The TurtleBot 4 is a robotics platform that uses the robot operating system, specifically ROS2, and it builds off of iRobot's Create 3 platform. So you can think of it like a Roomba without a vacuum cleaner, with additional sensors and a Raspberry Pi computer. One thing that is nice about the TurtleBot 4 is that it solves a lot of engineering problems so that someone who wants to try an idea doesn't have to invent their own robot, write motor and sensor drivers, put it in simulation, and figure out how to do navigation, etc. It's for this reason that previous generations of the TurtleBot have been used as a learning platform for education and to test ideas out for research. I've also seen a number of startups use a TurtleBot as a mobile base in their early prototypes. It was interesting talking to Adrian and Tony about the goals and design decisions of the TurtleBot 4, as well as hearing about how they've listened to the community to make an already popular platform even better from the perspective of their users. I'm Audrow Nash. This is the SenseThink X podcast. Thank you to our founding sponsor, Open Robotics. And now, here's my conversation with Adrian and Tony. Hi, Tony. Hi, Adrian. Would you guys introduce yourself? We'll start with Tony.
Hi, I'm the software manager at Clearpath Robotics. I work on the TurtleBot 4 project.
And I'm Adrian Popielas. I'm a mechanical designer at Clearpath Robotics, and I worked on the TurtleBot 4 as well, doing the mechanical design.
Mm-hmm. Now, just as some background information, what is the TurtleBot 4? Adrian, want to kick it off?
Sure, the TurtleBot 4 is a learning platform for robotics. It's the first learning platform to actually run ROS2. The robot, it was designed with a sort of out-of-the-box, easy-to-use sorry, just so
No
the
worries.
robot was designed to be easy to use out of the box, so that students or hobbyists can learn to work with robotics at home or in the classroom as easily as possible.
Gotcha. And Tony, what does it look like?
Well, there's two versions. There's actually a light, which is a Roomba with a bit more on top. And then there's the full TurtleBot 4, which is the Roomba with a few plates on top for mounting extra accessories and adding a few possible payloads such as sensors or even like little arms if you have onto the robot.
Cool. And so it's not exactly the Roomba, it's the Create 3, right? So it looks like a Roomba, but it doesn't have a vacuum. Is it correct, or is there any other
Yeah, that's
difference?
correct. So my understanding is that iRobot, they released the Create 3, which is essentially their Roomba platform with all the vacuum features removed, but all the sensors are still there that are relevant to any other sort of robotics project, like the cliff sensor, bump sensor, and all of that fun stuff.
hmm And what is so when we say we're taking a Create 3 and we're adding stuff onto it, what additional like feature, why are we adding stuff onto it? Why not just use the Create 3 as it is?
Yeah, so uh, like I mentioned before, we wanted this to be as much of a pull it out of the box and start running it as quickly as possible. One of the targets was to be able to run SLAM within 15 minutes. So both the light and the standard TurtleBot 4 come with the RP LiDAR and also
hmm
an OAK-D camera. For the light, it's the OAK-D Lite, and then for the standard, it's the OAK-D Pro. So you have the depth sensing vision as well. And so that way, both the TurtleBot offerings have all the Create 3 offerings, but with the addition of the LiDAR and the camera for easy out-of-the-box SLAM applications.
It's awesome. And then so Tony, you worked primarily on the software for this, or you were overseeing it.
Yes.
How did you make the software towards the goal of being easier to use versus whatever the Create 3 comes with?
Well, the Create 3 actually comes with a really nice ROS interface.
hmm
Um, So we just actually expanded on that. A couple of new drivers that you typically use, such as the RP LiDAR and the OD camera. And we made examples to use that for navigation using Nav2 to build a map and explore a room and provide tutorials for that. That's all integrated so that they're in the RDF, and we provide the simulation as well for these items as well. And the simulation is in Gazebo Ignition.
Gotcha. Awesome. And both of these, so we have the Create 3, and on top of that, you have these additional sensors, and you also have a Raspberry Pi computer, correct? So the Raspberry Pi computer is talking to the Create 3 and sort of delegating to it, or how do those work together?
So the Raspberry Pi 3 connects to the Create 3, and they use ROS to use the communication method to talk between each other. And the Create 3 interacts with all the sensors, because the Create 3 is a closed off system where it just runs ROS on its own, and it has the topics that you can access to publish and subscribe to, but you can't necessarily add a 3D LiDAR or 2D LiDAR to. So we do that on the Raspberry Pi, and then the user can interact with the Raspberry Pi from their laptop.
Gotcha. And so you kind of just, on the Raspberry Pi, you just pass messages along to the Create 3 and it executes them. So you can say, move your wheels with this velocity or something like this, or
Yes.
what does it look like?
It subscribes to command velocity, so you send it a twist message and it'll respond as if the wheels move a certain velocity.
Okay, and what does it look like if I'm a new user just getting started up with this? So I SSH into the Raspberry Pi, or how does it work?
Yes, so you'd SSH into the Raspberry Pi. You can definitely connect the screen, that's all there, but it doesn't have a desktop, unfortunately, just to save on space. So it's a Ubuntu server.
Oh, so you're saying the Raspberry Pi doesn't have like the graphics coming with it.
No.
So you can just access a terminal. You can't access the like GUI of the Raspberry Pi operating system or whatever it is.
So SSHing is the preferred method, and we added all this in tutorials how to SSH. So you'd go into that and then you'd start it, and then most of the interactions would actually be from your own laptop. Just because the Raspberry Pi isn't that powerful, and obviously it's moving around, so you don't necessarily want to have a GUI on a moving robot.
Yeah, for sure. And then Adrian, what sort of physical, like mechanical things did you develop, or not necessarily you, but were developed on the TurtleBot to make it easier to be extensible in these kinds of things? So if I want to try additional sensors or put an arm on, as you've mentioned, how do you make it so it's better for that?
Yeah, so the TurtleBot Lite, it is just the additional sensors on the Create 3, so you can just use the Create 3 platform as it was designed. It has a bunch of standard-sized holes, so it's a really great platform to build off of, which we obviously took advantage of that by building off of it. And so we have a riser that we've been calling the shell, because it's a TurtleBot. And that riser houses the Raspberry Pi there, and then on top of that is a PCB, which has I think it was a 2-inch OLED display, a bunch of user interface buttons, a few LEDs for status indication, and then user LEDs as well. And then above all of that, on some 200 millimeter standoffs, there's a shelf, which is made out of plastic, so the user can go in, take the shelf off, drill holes into it, or attach other sensors, or attach an arm. And so it's very, very user friendly in terms of how you can modify it and like make it your own. Do with it whatever you need to in order to learn how to use robots.
Yeah, I've heard about the like plastic shelf approach, which because it's plastic, it's cheap and you can destroy it. And just buy another one once you put a bunch of holes in it to mount some sensor on it, and then you're going to put a bunch of you want another sensor that and needs a different hole configuration, or you want it to be cleaner, or whatever it is, and you just buy another one and then do that. Why go with a plastic shelf as opposed to like a metal shelf with a bunch of holes already in it? I guess you don't know the size of the holes that you
Yeah,
want or
exactly.
things like this.
Exactly. So one of the sort of industrial design goals of the robot was to make it look as nice of a product as possible.
Hmm.
Other TurtleBot designs, they were great for what they were doing, but they leaned a little more into the hacky territory of design, if you will.
Yeah.
One of them had the netbook kind of like placed onto a shelf, which, that's great, it works, but it doesn't look
What is a
like a
netbook? Is it
product.
like a Raspberry Pi alternative or?
So netbooks were these low power laptops. They were
Oh.
sub 14-inch screens. So TurtleBot 1 and 2 used them. Um, they weren't really supported by a lot of manufacturers, and that's why you've probably never heard about them. They were just really small netbooks that you could put onto the robot. This was like before Intel NUCs, before single board computers like the Raspberry Pi. Um, so they're the quick way to put a computer onto the robot. They have the full desktop, so they're actually kind of easy to use, like in the sense that you could pull off the laptop and use it. But
Hmm.
they just weren't well manufactured. They're usually Intel Celerons or lower power AMD chips. They would break constantly, and we had a lot of supply chain issues with them because a lot of the companies would
Mm.
stop producing them.
Yeah.
Um, and just their overall hardware was very subpar. Some of them we got with fast Ethernet, which after 2010 shouldn't be a thing, but that's what they were shipping with. So it was just a hassle to constantly have them around.
So that sounds like one of the big upgrades for this recent TurtleBot. Um, what other things are different between, was that TurtleBot 3 or TurtleBot 2
That
that
was
had the netbooks?
that was sort of about two.
Ah, okay. So can you kind of, I'm not sure if you guys know the history of both of these, but it'd be interesting to see what's different between the TurtleBot 1, 2, 3, 4. Like what has been the evolution of the TurtleBot? Um, I don't know, jump in because I don't know which. I guess you can both speak to the perspective that you have, which is hardware and software. But what do you
So
think?
I used the TurtleBot one when I first started learning ROS in university. Um,
Yeah.
it was a netbook. It was the Kinect camera, um, and it worked. The netbook wasn't bad, um, and for all intents and purposes, I learned how to use ROS on that system. When the TurtleBot 2 came around, it switched from the first Create, I guess. I don't know if it was actually Create.
I don't think it was actually Create. Um, I don't recall what it was, but I remember looking back at previous versions, and if I'm remembering correctly, it was some other brand that we used as a
Okay.
base platform.
For the first one, it was definitely a robot. The second one was a Kabuki from Eugen Robotics. And then the second one wasn't that different. It was just the base kind of changed.
Hmm.
The second one was nice because they added user power supplies, so you could kind of run your own systems. Whereas the first one, there really wasn't an option to get extra power from the iRobot base that was being
Mm.
used. It didn't have a built-in IMU. There was like a secondary PCB there. Um, and then TurtleBot 3 came along from Robotness, which was totally different. That was the first one to use the single board computers. And there was the two variations, the waffle burger, I think.
Oh yeah, I remember those.
They were kind of like 3D printed. Um, so that was the first one to also have like a microcontroller on board. That was kind of programmable and extensible. I'm not sure.
What was the purpose of the microcontroller on it? You'd be doing some like low level device interfacing with it, or what would you do with the microcontroller?
I think that was the goal, to be able to
Oh,
interface with some lower level devices. Um,
so it just had a bunch of pinouts and you could connect stuff into it. Okay.
and then I don't know if you ever heard about the TurtleBot Euclid. That was a product from Clearpath that
No.
kind of Didn't really make it to
Like
market.
Euclidean space, like XYZ kind of
Yeah.
thing?
So it was based on this all-in-one system from Intel called
Mm-hmm.
the Intel Euclid. So it's a depth camera, IMU, and computer in a very small package.
Mm-hmm.
And that was going to use the Crate 2 from iRobot as well. Unfortunately, Intel canceled the product, and there was only a finite number of units.
Oh, it died. Yep.
So because of that, Clearpath also decided not to bring the product to market.
Gotcha. Adrian, anything to add kind of from the hardware perspective? What kind of changes did we see? So we saw change of base. So we went from various different base types. They were 3D printed with the waffle and burger one, which they had all sorts of like holes for you to put things into. But how do you think of them progressing in terms of their hardware?
Yeah, I mean, we were talking about the shelf. I know that in at least the TurtleBot 2, they used, I think, MDF boards for
What's
shelves.
that?
So
I'm
it's
not familiar with.
it's a type of wood that's just like wood powder that's compressed into boards. Really cheap material, very easy to work with. But again, it's a wood, so it didn't look quite as nice in terms of product.
Looks very hacky.
Right,
Mhm.
exactly. Yeah, so going back to what we were discussing earlier, where, the plastic shelf gives it more of that sort of professional product look. So,
Mhm. Gotcha. So it would be fair to say that this one is. So there's a few things that are kind of special about this TurtleBot 4, in my mind. So the first one is it was designed to look good. So as it be more producty, because I've heard of several startups using the TurtleBot platforms as like a really early way of prototyping an idea. And also, as you mentioned, it's for education. So like for the startups, they put like an arm on it and demonstrate their use case. And so they'd put that in front of, say, some angel investors or maybe some like, I don't know, some early investors. So that's one of them. And then another one is that it's ROS 2. So it's the first one with ROS 2. And also that plastic board is kind of nice that you can just take it off and replace it, but it looks nice. I guess that lumps into point one. Are there other things that kind of you see as big improvements or big selling points to this new TurtleBot?
yeah, I mean, we had a presence at ICRA this year,
Mm-hmm.
which I don't remember the what ICRA stands for again. But it's
Just the
a
big academic
conference.
robotics
Yeah,
conference,
exactly.
like the flagship IEEE
Yeah.
robotics conference.
Yeah. So we had a presence there with some TurtleBots. We had one TurtleBot doing like a demo, and then another TurtleBot standard sitting there. And from what I've heard, a lot of people were very excited about the display. It's the first time that TurtleBot has a display, which is really helpful for someone learning. It displays the IP address of the robot, so you can easily connect to it
That is so
without
nice.
having to dig through. Right, like it saves you a couple minutes over time that adds up, right?
Yeah, and it's always
and if
so painful if you
yeah,
have to go and like grab a screen, plug into it, SSH it, or I mean, like I don't know, look in with the monitor and then find the IP address and then connect to it remotely. Now that you know the IP address, it's always so painful. So that's a big improvement
yeah,
in terms of
exactly.
workflow.
Yeah, a lot of people were very excited about that screen. It's also an easy way to access some of the abilities of the robot. So I know that one of the menu options on that screen is to dock, right? So you can easily just hit two buttons to select dock and it just goes, right? So you don't have to, if you're having some issues with, connectivity or whatever, you can just make it go back, start charging while you fix whatever issues you're having, right? So just that user interface is really exciting. It's really cool. It makes the whole robot a little more user friendly, a little more appealing to use.
Mm-hmm. Yeah, it's a little like the user or the I don't know usability of it has been greatly improved. Tony, any other things on your mind for kind of the big improvements for this TurtleBot?
I think along those lines, like those buttons are user programmable. So if you don't want them to be docking, you can change them to whatever you want them to be.
Mm-hmm.
I mean, you can connect it and have it, run navigation and start building your map. Or depending on what you're developing, you can have it do whatever you see fit. So I think that is great, where you literally can just walk up to it, press the button, and it can execute something whatever you want specifically.
Mm-hmm.
I mean, I can't get over that because that was something that I really want on
It's
all
frustrating.
robots.
Yes, me too.
Um,
That's such a funny thing that's such a pain point, and it's like such a little simple fix to add a, I don't know, $5 display on there or something like this, where it's like an inexpensive thing, but it's such a value add for the consumers or for anyone who's using it for that matter. Um, Speaking of like $5 display, what's the price point for this new TurtleBot?
I don't recall the exact price.
I think, isn't it?
It was
It's
like
around
1500 for the light and 2000 for the standard. I'm trying to pull that info up really quickly here.
It's okay. That seems about right to me.
Yeah.
I mean, I'd like, it's definitely correct in terms of like order of price. Like, so it's around there. It's around 1500 or 2000. But the interesting part to me is how do you pick the parts and development efforts that go into that? So maybe Adrian, can you talk a bit about the hardware and kind of how you've picked the hardware to stay under, or even actually backing up a little bit.
Mhm.
Do you guys know how the budget was picked to make it around 2K?
So I don't know if we really had a target budget. It was more like we want to have these sensors into it, and how do we
Oh,
make it affordable? And then afterwards, once we got everything together and we figured out how much it actually costs, that's when we were able to put out a price to try to make it as competitive as possible. And yeah, so like part selection that was done based off of previous experiences with parts. So I think Tony mentioned that we've worked with the RP lidar on some stuff before. The OAK-D cameras, we got into a partnership with Alexonis because their cameras looked really exciting, and we wanted to get those on our product as well. And even just from the Kickstarter, you could see the value in those
the
cameras.
interest in it. Yeah,
Yeah,
very
and
successful open. What are they open
exactly.
source?
Yes, yeah,
And then they were funded on crowdfunding and they blew up
exactly,
on that. Okay, so
exactly, and for a really affordable price too. So
yeah, very exciting. How does it so if I understand correctly, you're saying you basically started with a set of sensors that you wanted. So you said I wanted to have a planar lidar, I wanted to have a depth camera, and then other were those kind of the two critical sensors or anything else?
yeah, those were the two main sensors that we wanted to ensure we had in there.
Mm-hmm.
Like I said, one of the main driving factors was wanting to be able to get a slam experience right out of the box, and so
Yeah.
those are kind of two things that you really need, and were sensors that we absolutely had to have on the robot.
Gotcha. So you wanted those sensors on the robot, and then from there you went and looked for different hardware that for those specific sensors to try to figure out what was the cheapest, most reliable, like ones that satisfied several criterion. So they needed to be reliable, they needed to be as inexpensive as possible, these kinds of things.
Yeah, essentially that was the case, without going overboard in terms of as cheap as possible. Because, like you said, reliability is important
Yeah,
too, right? We
you
don't
don't want
want
something that'll
people.
just break that in name is
Exactly,
a LiDAR or something like this.
exactly. Yeah.
Gotcha. And then, so from the software development perspective, Tony, how did you? I imagine it's like, and I may be wrong about this because I don't exactly know how Clearpath would work with this, but I'm imagining if it was like how Open Robotics does things, you have a certain number of like man hours to work on the software and get it to like the best state that you can do in that time? Or what's the, or how did it work from a software developing perspective? Because the more time that you spend on it as a software developer or your team, probably the higher cost it would be for consumers to kind of get that the time back in terms of selling these.
Yeah, I think we had a time allocation for all hours, obviously, and we probably went over as is typical.
Yeah.
But I don't think the majority of the cost does come from the software. I mean, it's very reusable. We use a lot of open source libraries, made smart design decisions. We didn't really want an MCU, so the Raspberry Pi actually drives the screen.
What's MCU?
Oh, sorry, microcontroller.
Ah, okay.
So it's nice to have a single board computer to actually control the LCD screen. Typically, on other robots, we have a microcontroller to do all that stuff. So that would reduce costs and also reduces development time. So we don't have to develop firmware for that board. So that's all done in Linux. And in terms of other development, the base was already done with done from iRobot. So just interacting with that. So it was just about putting together a nice URDF and making sure all the sensor drivers work, which some of them we have experience with, and some of them already have ROS SDK, so it wasn't like you're writing drivers for them. And just putting it all together and making it look like a nice robot package like you get from Clearpath in general. We did that. And getting all the code out and distributed in binary forms.
Gotcha. How do you, so you mentioned smart design decisions. What were some of those?
Definitely removing the need for my controller to do the low-level control. That way, that we can only write one set of code to access I2C on Linux, and that would be usable for the Raspberry Pi or other single board systems that have an I2C interface. And then that'd be one set of code you have to manage. You don't have to worry about how to upload the firmware onto that second board or even maintain anything for it. And software and electrically, you don't have to have that board developed there.
Gotcha. So removing that board, that was kind of the biggest, or that was a huge win, because you don't have to maintain, and it makes testing easier, and there's all sorts of like benefits to that.
Yep.
How is the software organized on the TurtleBot?
So
is it just you have a ROS workspace, or what's it like?
So,
and you said binary files, so I guess it's your. Oh, go ahead.
Yeah, so we're trying to distribute them as binaries so you can apt-get install them in all the various flavors that Open Robotics' built farm supports. So there's a few repositories. One is the common one, so that would be the messages for the TurtleBot for specifically the URDF in the description and the control package, because that has to be shared between two systems. And there's a robot package that contains the TurtleBot 4 base code, any bring up code that's specific to being on the robot, so that's not something you need on your computer or any other additional computers interacting with it. And the last thing is the simulation package. So that contains all the simulation stuff that you need for Gazebo. And so that way that all this code separate. So if you want to build a workspace and edit them, you're not pulling the Gazebo code onto the robot. Similarly, if you want to work on Gazebo, you're not pulling in the drive code onto your system.
Yeah, that's nice. Because especially with the Raspberry Pi, that would be really painful to try to run Gazebo on it. So that's very nice that you can have that separation. What, let's see, going into the hardware, were there any smart design decisions that you guys did, Adrian? Like any things that really saved you a lot of effort down the road?
Well, honestly, throughout the entire process, one of the key factors was design for manufacturing, right? Just because we assemble the robots here, So we wanted to make sure that we're able to get those robots out the door without too much effort. And with all the components that we're bringing in, the actual assembly isn't that difficult. You're just adding the shell, adding on the Raspberry Pi, and then installing the PCBA, connecting some cables, attaching the shelf, and you're done. So like it's definitely designed for manufacturing was a key factor in that. And so that was always something that was at the forefront whenever we were working on the design.
How do you design for manufacturing? Like, what are some heuristics that you can use? I guess like fewer parts, fewer screws. Like, what are the kinds of things that you try to do to make it manufacture as easy as possible for
Yeah, for sure.
manufacturing?
Yeah, so actually, I have a concrete example of an instance where that happened. So initially, the shell that we had, that plastic shell, had these bosses that would hold a. They're very tall because I think the shell is like 52 millimeters high. The bosses were hollow so that a screw could kind of like fall in there, and then you would screw it down, and that's how you attach it to the plate.
Okay.
Now, obviously, dropping a screw down a 52 millimeter hole and hoping it lands in the right position is a little annoying. So one of the things we did was we just cut off part of the bosses, so you have easy access while installing. So now it's just right there. You can put your screw in place, tighten it down, you're good to go. And
Yeah.
we have 8 screws, I think, holding it down. So kind of playing darts with a screw 8 times per robot would definitely slow you down. So that's something
For sure. You'd have to like jiggle it to get it in otherwise, and that would
exactly,
be really annoying.
exactly,
Yeah.
yeah,
How funny. Yeah, screws are such a pain in manufacturing. It's so funny.
yeah, yeah,
So then you have you have your set of sensors that you really want on it, and now you start designing around that. And then the price just kind of becomes whatever it will be for this. And is that kind of how it worked? I'm wondering like if you interacted, because I know this is for education, did you consider what universities are willing to pay, or what hobbyists who are kind of more serious are willing to pay, or I guess going from the we want this sensor so that we could do SLAM in 15 minutes, how do you get from there to the price point that the TurtleBot has arrived at?
I think
yeah. One of the oh, go ahead, Tony.
well, I think a lot of our costs were fixed. Like we got the iRobot Grade 3 base for a fixed cost. The Raspberry Pi, we got for a fixed cost. So there wasn't that much extra hardware that we had control of. But I think we did want to target the around the same price as the current TurtleBots. And then I think Adrian can speak to how much our additional software, our additional hardware costs.
Yeah, I mean, similarly, you approach different vendors for different parts to try to get the best price possible. And once we had everything integrated, the hope was that we could get our price to close to what the current TurtleBots, the previous generation, cost, so that you wouldn't have that sticker shock to someone who wants to enter the ecosystem, right? So that way, yeah, we tried to find lower costs where we could, but some things are just going to be whatever they cost, right? So
Yep.
in the end, it was an attempt to not compromise too much, let's say, because that way, we didn't have to say, okay, we have to get rid of the camera because it's going to cost us too much, but then you lose some critical functionality, right?
Yeah.
And you could swing it the other way and say, oh, we also want this other sensor and this sensor and that sensor, and it just becomes
And the kitchen sink.
too
Yeah.
much. Exactly. Yeah, and part of the fun of the TurtleBot is adding your own sensors and seeing how you can make it interact. So the critical sensors that we put on there, the LiDAR and the camera, as well as what comes with the Crate 3, were sort of the guiding posts for the price and sort of the design of the robot.
Gotcha. Did you guys experience issues getting parts from supply chain issues? Like the Raspberry Pi, I imagine. But
Yeah, I mean, I feel like that we were hitting supply chain issues constantly with everything. The electrical engineer who's working on the PCBA that's on the standard, I think they had selected a component for the USB driver, and then 2 weeks later, when we went to order parts for it, they were out of stock. So now we had to do a redesign
Yeah.
with a new driver, which is delaying things again. Luckily, we were finally able to get our hands on some stuff. I think we also, in certain situations, if we saw that there was a lot of stock for components, we would order them ahead of time because we would know, okay, we're going to be using this for sure. Let's just order for X amount of robots, and then we'll try to find more stock later.
Uh-huh. Are you in danger of running out of stock for the TurtleBot, or how are orders so far?
I don't know about all of the components, but I know like the Raspberry Pi, we're good for at least the rest of this year.
Nice.
And I think we have leads for future orders.
Oh, that's crazy.
And I know that one was a big, scary moment because, the Raspberry Pi is sort of the backbone in terms of driving the
For sure.
unit. So when we were running into that wall, that was a bit of a scary moment, but we managed to find some alternative sources. I actually think for the first build, we ordered these development kits that come with cables and SD card and all this extra stuff that we don't need. We put it into our own stockpile, so we have extra USB cables now for any other future projects that we're doing. But yeah, so we just found alternative sources for these
Gotcha.
parts.
So are you saying with that, is it like you're buying things that are kits that have the Raspberry Pi that have other things you don't need? Now you're just going, we'll use these maybe for the other components that are not the Raspberry Pi? Is that what you mean?
Yeah, so with our first build, because we were trying to get, the first 50 built as soon as possible, we needed them quickly. And so I think the first alternative bulk order was a couple months out. We wanted these first 50 in hand, so we bought these kits that had, heat sinks and some other
all this
bits and bobs that
unnecessary
we didn't
stuff.
need.
Yeah. That's funny. How crazy. Did you I wonder if you would see it. Have you seen anything of like inflation in the parts that you're getting in the last few months for this? Or I don't know, any observations there? I don't know if you'd see it directly or what kind of thing.
Not from my end. I haven't really been paying attention to the cost of our parts anymore. Since I've
Yeah.
done the design, it's all good. Now everything is up to purchasing and production, right?
Gotcha.
So I'm not too sure about that.
Gotcha. So Tony, so you've mentioned a couple times the URDF, so having a good URDF so you can use the robot in simulation. What was involved with all of that? How do you, well, first actually, would you describe what a URDF is and what it's used for, and then how do you get a good one?
Sure.
For our TurtleBot 4?
So URDF is the Universal Robot Description File. So that tells the robot basically where everything is. So once it gets parsed by the URDF parser, I think it's the Robotics publisher that does that. It puts up the links in and it has all the visual meshes and also the collision message. So those can vary in terms of, you might have a mesh that's the visually one size and the collision one can be bigger depending on what you need. So this,
and when you say meshes, you mean kind of like the 3D rendering of it. So if it's so it will look like the 3D model of the Create 3, for example. And then you're saying that you can have the collision part and that will be separate from the mesh, like the visualization part. So you can have maybe a cylinder, like a perfect cylinder, be the Create 3 collision mesh, right?
yes. However, that was not the case for this because we just used the normal meshes. But in some
directly.
In some use cases, you might want to make it a bit bigger just because the top might not be a front surface, perfect surface, or you're worried about something colliding. So you just make it a general shape, like you said, a cylinder instead of the actual model. So the Create 3 comes with that. There's the Create 3 description for my robot. So we take that and we add the additional meshes. So Adrian would export them from the CAD models of the robot, and then I would complain that they're too big and try to scale them down.
Yeah.
And then those get put in.
Because by default, they're really detailed, right? So if you have the CAD model, it's like tons and tons of little triangles representing the mesh. And thus it's enormous, even though it's representing a fairly simple shape. Correct?
Yeah.
Gotcha.
So
luckily, there's a slider that makes it much simpler and much
Oh
more
yeah.
triangular. So
Gosh, I've seen instances where like a person who's an actual artist will go and kind of delete the triangles or like merge them so that you can get fewer triangles to represent the same shape approximately. And that's like time consuming and they have to really know their stuff to do a good job with it. But you used in your CAD software, you just said do lower resolution and that worked out. And then you sent them to Tony, Adrian.
exactly. During the export process, there's an option for coarse or fine meshes. So you just slide it all the way down to coarse and then hope it's small enough at that point.
Okay, so then you'd use these meshes, Tony, and then where from there? So you position them in the file, or how did it all work?
yes, in the file you define a link, and that's where the mesh's origin is. So if you had, let's say, a sphere, it'd be like inside the sphere, and you tell it that where it is relative to the other links. So in the crates instance, there's a base link, which is like the center of the robot in the middle, but that's not very useful for measuring and adding additional sensors. So there's actually the top link, the top plate link, which is where somewhere you can actually measure from, and that's where you can add additional sensors. So in that, we have the URDF also has the RP LiDAR and the camera visual meshes, so you can visually see them once you're onto ARVIS, and the shell and the shelf plates as well.
Gotcha. And so when you're visually measuring, you're using like calipers or what to like actually measure parts, or how is it?
So
I guess you use the CAD models, or
Yeah, that's where I came in again. Is just it's a easy measuring tool in the CAD. I just send the X, Y,
grab here, and it's like
exactly.
that distance is 6 inches or whatever it is. I see.
however, for a user, they could actually measure from the more defined link, so they can measure from the top plate instead of trying to find the base link, which is somewhere at the bottom of the robot.
Mm-hmm. Gotcha. And then so you have this URDF file. This URDF file describes the robot by having all these links and joints between things. So you have like a link, and that'll be the base, and then you have the next link, and that'll be, and I guess they're connected by joints. You could have like a fixed joint or whatever it is. I don't use URDF too much. I'm always on the software side for things, but then you have your joint and the next link, and so you kind of describe the full robot by these components that are all connected, and then you use that in simulation.
It adds to the simulation. Gazebo has its own description file. I think it's SDF, single description file, where it defines a lot of the stuff, but it gets pulled in at simulation into that file, what I recall from Gazebo.
Okay, and then you need to write all sorts of like ways for Gazebo to understand, and Gazebo as a simulator, you need to write ways for it to understand what the motor commands do and all sorts of things, right? So did you have to write plugins for that? Or I'm very naive with how Gazebo works. I haven't really been on any projects with it, but what kind of things did you do so you could move the robot around in simulation and use its sensors and all these things?
So iRobot did a great job in the sense that they made the plugins to simulate a lot of the Create Theory's features. So I think the majority of the robot features are simulated in Gazebo. So they have those plugins, and then we use some of the standard Gazebo plugins to add additional sensors. So there's a Gazebo plugin for an RGB camera, and we just applied the settings that OpenD would have and use that as the OpenD's plugin simulation.
So you mentioned, Tony, at the beginning that you spent a lot of time on examples and tutorials. Would you tell me a bit about I guess, examples first for people? I guess they can kind of be lumped together, but what, how do you design those, and what kind of examples exist?
So the majority of examples are centered around navigation and using Nav2, which is the ROS2 nav stack. So it'd be about creating a map, using the map to navigate, going to a particular spot on the map. There's also more basic tutorials, such as writing a C++ publisher and writing a Python publisher. We did those just to interact more with the robot. So if you want to just help it drive a certain way, you can do that using those two languages. Can't recall if there's any what other major tutorials are, but a lot of them are centered around that. And then obviously there's a gazebo tutorials explaining how to use a simulation to achieve the same stuff.
Mm-hmm. That's cool. Is there any, I wonder, if I wanted to run this in like Amazon's RoboMaker or anything, is there any difficulty do you just upload your URDF? And I don't know, I haven't really used it too much. But I guess how is it to use all these things elsewhere? Like off of the robot. If I guess for the gazebo it's easy. Yeah, I don't know.
I mean, in terms of
Let's see.
all the software, it's all binary deployed. So if you want to install it anywhere, it should be quick to install if you have, especially if you have ROS2 installed. And as long as you have a head unit, you can run gazebo, no problem. And it should be the same as the robot, ideally.
And so now this is the first TurtleBot to use ROS2, and you said the first educational platform to use ROS2. What are some of the things that ROS2 lets you do, or are there any advantages to ROS2 from your perspective of this?
The first thing is the lack of the lack of the ROS master. So having a decentralized system is definitely huge. Maintaining the multi-computer systems was always a thing with ROS1. I found. So that's
because then the order really matters, like the boot up order and things like this, where you have to start your ROS core on one, and then the other one has to go and listen to it, and like the networks both have to be active, like this kind of thing.
Yeah.
Or if one is dropped, that like say the core is dropped or that computer, then the other one fails because of it, and then it's not very fault tolerant.
Exactly.
Because you don't have distributed control. Yeah.
So that's definitely a big thing, and then the performance of using DDS is nice because we do use the Raspberry Pi's built-in USB that kind of acts like an Ethernet, but it's nice that it also acts like another interface that DDS understands how to use. Like you define it in the DDS parameters, and like it's not like it's an interface, but it's not like Ethernet. Like you couldn't specify an IP address to it. From what I recall. So it was nice that you could actually just use that interface as a way to talk to ROS2.
So it made it easier for different systems to talk because you didn't have to like coordinate their IP addresses and things. They would just talk because they're on the same network in some sense. Yeah. Or gotcha. Any other advantages to that, or how was it using ROS2 from your perspective or your team's perspective?
It was a bit of a learning curve. That the TurtleBot 4 was actually the first robot of Clearpath like fully in ROS2. There was some hiccups with DDS versions and which vendor supported what.
Which DDS vendor supported what?
Yeah, I think.
And just for the listeners who aren't aware, DDS is I don't remember what it stands for, but it's do you guys remember what it stands for? Distributed data structures or something like this.
Something along those lines.
It's basically a middleware, so it's like TCP/IP or UDP, and it kind of lets you interpolate between the two, and it's well standardized, which is one of the big reasons to move over to it. Like I don't know, safety critical systems will use DDS, so that was one of the nice things about it being used by ROS2. But so yeah, it definitely can be confusing with all the configuration stuff. And I could imagine there would be hiccups for that. And then the DDS vendors don't support exactly the same thing, even though there is the standard. They'll like add on to it in different ways.
So that was the majority thing. Other than that, roster was definitely nice to work with. There wasn't, I mean, that much of a difference. It's just, I guess, the more modern C++. It was something I noticed.
Mm-hmm. Let's see. Adrian, from your perspective with the Create 3, was there any like, was that a nice step up as a base platform in your opinion? Or like, is there anything that it does really well that was, I don't know, just a nice addition?
Yeah, I mean, the top plate of the Create 3 has those standard um, sized holes that are standard width apart. So it was really easy to just like tap into those, use that to anchor everything else on top of that. It made manufacturing the TurtleBot 4 much easier. Yeah.
How did you choose to use the Create 3? I guess you used the Create 2 in the previous one with the Intel um Euclidean one or whatever it was. How'd you so was it just natural to use the Create 3 or how did you decide to use the Create 3 as the base platform?
Yeah, there was a relationship that already existed between Clearpath and iRobot. So I think we were able to really easily work with them. And they were going to be introducing the Create 3 around the same time. So it was just a really great opportunity for both of us to, work together and, yeah, introduce our products together.
Nice. Was there any like weird scheduling related things where it's like, I mean, so for example, like trying to go to the latest Ubuntu version, if they make a change right at the very end, then that's tough if you're targeting it. And if you're targeting a physical platform, I don't know if like something changes, if that makes it harder um, for you guys as developers on it, or I don't know. Was there anything like that, or was it a nice smooth process?
In the course of development, iRobot upgraded from Foxy to Galactic. Um, that wasn't a big hiccup because they're both installable in the same OS.
Mm-hmm.
Um, but typically at Clearpath, we only support the LTS versions of ROS 2. And LTS means the long-term support editions. Those are the versions that have the long lifetime of support, whereas the non-long support editions have 1 year of support. So we typically don't tend to use them.
Yeah, so that's like Galactic was 1 year supported one, I believe, and it's so and then Foxy, I don't remember how long Foxy supported, maybe 3 years. Humble is supported for 5 years. I forget if Foxy was like a full LTS, but so yeah, so you don't target that, but they switched the ROS2 um version or distro to Galactic in the thing.
Yeah.
Okay. Do you think so? You guys are using Galactic, I take it, on the TurtleBot 4. Is that correct?
Yes.
Do you think when it goes EOL, when it goes end of life, you'll switch to Humble or back to Foxy, or what do you think? Or you'll
Um,
just track whatever um, the the Create 3 does, or what do you think?
we'll try to track what the Create 3 does, just because it makes sense to keep up with them.
Hmm. Yeah, I think mixing between ROS distros is not really supported, although it probably is possible most of the time. But you might get some really, really weird errors, I would imagine.
It becomes a lot harder with DDS versions because the default DDS version
Oh,
does change.
between versions, you're right.
Yeah.
Gotcha. Yeah, I wonder. Going to Humble was a pretty large migration. I mean, you go to the next Ubuntu Jammy 2204, and then there's a lot of things that are different, the Python version and the DDS version, as you were mentioning. So that was a tough migration. I was the ROS boss for Humble, and there was a lot of fallout when we tried to switch from focal to humble or focal to jammy. Let's see. What I'm trying to go back to the mechanical side of things. Was there any like interesting problems or set of constraints that you were working with for this?
Yeah, actually, we did run into design consideration, let's say, that iRobot kind of brought up as well, which is the fact that the Crate 3 has like the two main drive wheels and then a caster at the front where the buttons are. And one of the design considerations was that we wanted access to those buttons, which means that our payload is more towards the back of the robot where there isn't any support.
Okay, so it's unbalanced in a
Right,
sense. It
yeah,
might, like,
especially
tip.
if you start driving at a very fast acceleration. So,
Yep.
yeah, so through testing, we kind of figured out what sort of acceleration works best. Also, it drove some changes in terms of mechanical design. The platform was originally a little higher up. We brought it down a little bit. Also, the camera bracket that we have in there, that was shifted over to kind of push the weight a little forward.
Mm-hmm.
So just like little changes like that happened. And then actually about a month ago, I think iRobot shared some solutions for that with like a 3D printed caster adapter. So you can add a caster now. But yeah, so
To make an extra contact point.
Yeah,
And then
exactly.
I see.
Yeah, so during development, that was definitely something that came up, and we just worked around it, altered our design. We adjusted the default acceleration and speeds, that
That's
kind of
funny.
stuff. So yeah,
So you don't accelerate too quickly ever, so it doesn't tip back while you're trying
and
to
like
go.
you can make it tip back if you want it, but
Yes.
you definitely that's not ideal. So
Yeah, for sure. Gotcha. Let's see. Speaking of that, how did you do testing for this? How did you make sure everything was working? And let's start with kind of the physical thing. Did you just, or the mechanical systems, did you just like put it through its paces and run it for hours and hours, or like what kind of things did you do to test the physical systems?
Yeah, so obviously we had some specs that we were targeting based on the Create 3 platform and sort of previous TurtleBots as well. We wanted
And
to make sure we could.
by these specs, you mean basically the Create 3 will say, I can do this, and you want to make sure you're not limiting those. You want to make sure that you're giving the user the full capabilities of the Create 3. That's what you mean by that? I see.
Yeah, yeah. So we want to make sure that our payload, the payload that our user can put on there, is high enough and matches the Create 3 as much as possible. Obviously, we're adding our payload.
Yep,
But
so that's to subtract, for sure.
exactly. But even so, we weren't putting that much on there, so we were pretty much like right there. And so we were running tests where we would put 9 kilograms and 16 kilogram weights on the robot and setting it up a 25-degree incline, making it go up, then turn around, then come back down.
That's a big
Just
incline.
making sure. Yeah,
Okay.
yeah. It was it was definitely a stress test.
Yeah.
We ran into an issue as well where for some reason if you would lift it up it would activate a kidnapping script or something where it would the robot would freak out, it wouldn't want to run
Really?
anymore. You'd have to reset it. There was a period of time where we were trying to do that. For some reason when we were doing these stress tests, that's when it came up. But we worked with iRobot and we were able to solve those issues. And then, yeah, like you mentioned, ran it for hours, doing like life testing, battery testing. I'm a mechanical guy, but I got to dip my toes into some more software stuff, which I haven't done in a while. Wrote
Nice.
a Python script to make it, twist in place until the battery died while recording at the battery level. So we have a nice, battery curve to make sure that it lasted at least, I think we were targeting at 2 hours or an hour or something like that. So.
And it's because you were having your add-ons to the Create 3 were additional power draw and things like this,
Yeah.
and so you wanted to make sure they were not that much of a power draw. So you didn't deplete the battery like rapidly. Like you drive 5 minutes off of the charging pad
Exactly.
and it's already dead. That would be
Yeah,
lame.
yeah, exactly. So we were running different tests on the two different platforms. So one of them was just idle battery draw, which lasted for a very long time. That wasn't an
Hmm.
issue. Then afterwards we had a motors only battery draw, so it was just twisting in place
So you
with
have the
nothing else.
baseline basically.
Exactly, yeah. And then we had like a full load test where it was running slam and nav2 and just everything in one at one go, and then twisting in place as well.
Gotcha.
And yeah, I think we were able to get over an hour of runtime, which is sort of what we wanted to include.
Gotcha. Awesome. It's funny. I love the robot tests where they just run it forever.
Mhm.
And like until the battery goes and this kind of thing. There's something satisfying about that for some reason.
Yeah, yeah. I mean, I will say though that the draining the battery to zero did
It was
give us
bad for
some,
it.
yeah,
Oh,
that you never want to do that. And it's something that pushed us to include some safety features for that. So
oh,
at a certain percentage, I can't recall it, like there's a warning light, and then it'll shut off at another certain percentage to preserve the battery.
gotcha.
Because with
At
that
like
lithium ion
5% or
battery,
3% or something like
I think it
this.
was actually higher than that.
Oh,
Yeah, I think
wow.
typically with lithium ion batteries, you don't want to drop it below 10%.
Oh, okay. Yeah, I know very little about batteries, but that's awesome. Oh yeah, it's nice to really know what your system can do and characterize it, and then try to see what fails first. I
Yeah.
imagine with buying the Create 3, iRobot has done some pretty intense testing on it just to make sure it's reliable. But then you were testing how your system impacts the performance over time and this kind of
Yeah.
thing. That sounds good. Did you
Yeah,
do
and
any
we were
sorts?
really like stress
Oh, go ahead.
testing and like pushing it to the limits, past its limits, to be honest. Because yeah,
Yeah, well, you
like
have
I
to,
said, you shouldn't be. Yeah, yeah.
for sure. Did you do any like user testing for this? Like bring in developers or bring in, I don't know, whoever else and like see how it is for them to use it? Or I suppose like you're using mostly open source software and so it's well established in the community and so it's not really your part of this, but I don't know. Did you put it in front of any people that were not, I don't know, any testing that was not you guys running the robot as hard as possible?
Um, the so actually going back to sort of the design process, when we were going through the buttons, I had ordered a selection of buttons that I had glued
Yeah.
onto a metal plate, and I left it out in the open in our office with a note saying, "Please press the buttons and send me a message and tell me which one you think feels the best." So that's how we landed on the buttons that we're using.
That's hilarious.
Yeah, yeah. I mean, it's that. I feel like that's probably the only instance where we did sort of
User
non-technical
testing.
testing. Yeah, it was just sort of yeah, it was interesting for sure.
That is funny.
We also did like a hack day for the engineering team to take the day and try to do something with the TurtleBot forum. These weren't people that were working on the project. These were just the rest of the engineering team trying to develop on the project, whether it was hardware
Mhm.
or software.
Gotcha.
Yeah.
That's nice. What a cool
Actually,
thing.
that's something that I'd love to share. I do have a photo slash video of a project that my team worked on.
Yeah, sure. Feel free to
We
share
had
it.
like four of us. Yeah, so we put
That's a
this
big
Ned
arm
2
for it.
arm. Yeah, so during the hack day, one of the things I wanted to do was really again stress test it. It's a 7 kilogram arm. I believe it was 7. Um, so I'll turn the volume down.
For
So
context, how much does the TurtleBot 4 weigh?
um,
I think 4 kilos,
yeah,
Gotcha.
four
so
kilos for
eight
the
and a half
standard.
pounds.
Nice.
Yeah, but yeah. So that hack day was really interesting. Um, it was really fun to put this really heavy load on it, attach an external battery, add that like rear caster wheel. It was quite the undertaking, but it was a proof of
Yeah.
concept that look, you can put this heavy load on it, you can put an arm on it, you can do all this really cool stuff with the TurtleBot.
Did you drive it up 25 degrees too?
Not
Okay,
that one, no.
that would have been nuts.
No, although I feel like you would be able to push it. Just,
Yep,
wouldn't be very happy.
for sure. And then, so Tony, what kind of testing did you guys do on the software side?
So our typical testing was that we left it running the whole overnight, again, till the battery died, and just flush out the system. A lot of the sensors we tested individually. Again, just leaving them running, subscribed, pulling out the data, making sure that all data is coming out and recording it, and just making sure that the driver would work for 20 hours, let's say, and make sure that there's no issues with it. Um, and just making sure that on the Raspberry Pi there's enough horsepower to run let's say navigation, and we found out there isn't, so you kind of have to set it up to run navigation more on your own system.
Oh,
There's settings in Tutorial to make it asynchronous navigation to use your computer and the Raspberry Pi. I think you can do it on the Raspberry Pi. It really
slow.
takes up all the resources. Yeah.
Gotcha. So with Slam and 15 minutes and this kind of thing, is it you have the robot running and then your computer is actually doing like talking and sending commands to it, actually doing the navigation, or is it more running locally on the robot?
I think it depends which one you choose. But the idea would be that you do all the heavy work, so the navigation planning and stuff like that, and you just send the actual drive commands to the base, and it drives. And the base will send you the sensor data, and you take that in, and you do the calculations and generate
On your computer or on the Raspberry Pi?
I believe you can do it on your computer.
Gotcha. Would it be possible to do with the Raspberry Pi, or is it you said it's super slow, or maybe it's like you're limited to a small room, or how does it work?
So I think with only the LiDAR, it's not very slow. Like it's definitely manageable on the Raspberry Pi. As soon as you want to actually use the depth camera, that's when it becomes a big problem.
Yeah, because it's a lot of data. I mean, a 3D representation of the world with all the rich depth information. So that makes sense.
Whereas the laser is just an array.
And especially if it's planar too.
Yeah.
Is it planar?
Yeah.
So it's only a 2D representation of the world you're getting, and you don't do any funny like tilting it or anything, so you can get like sweeping. Gotcha.
It is 360 though.
Yep. So it spins and does everything. Nice. What are you guys? What are you hoping for the TurtleBot 4? Like, what do you hope it does, or how, like the community response to it? Let's start with Adrian.
Yeah, so far the community response has been great from what I hear. Like I mentioned, the presence at ICRA, a lot of people were really excited. We had projections for initial orders, and from what we're hearing, like it's in demand and we're exceeding those projections. So I'm just really excited to see people, using it for their projects, seeing it in classrooms. I think it'll be really exciting just to see this project that we've been working on for quite a while now out in the world and in everyone's hands. I think that'll be really cool.
For sure. What are the sale, like how many units are you expecting to sell by the end of this year of the TurtleBot 4? Like ballpark. Is it like 5,000? Is it like
I
what
don't
are we
think
talking?
it was quite that high.
Okay.
I honestly cannot remember. I think we had initially projected like around 1,000 maybe. And it's pushing past that, so
That's exciting.
yeah.
And Tony, what are you kind of excited about for, like, what do you hope that this robot accomplishes in the community or in general?
I hope it gives like the future roboticists jump start to learning ROS and seeing how a ROS-based system works, and it gives them an opportunity to start with a well-defined base and then they can do all the crazy hacking they want on it because it is open source, and then they can modify literally anything they want on it.
Yeah.
And it just kind of inspires people to, you know, get into robotics.
Mm-hmm. And then wrapping up, what advice would you have for say someone who's in college um, and thinking about their career or trying to figure out where their career should go? Let's start with Adrian.
Mhm. Yeah, I mean, I think what's really important is to just constantly expand your skill set, right? Whether that is learning ROS 2 or learning Python or, learning about mechanical design, industrial design. The more you know, the more you can contribute, which means that will be able to, get yourself out there and continue to learn even more, right? Because I think something I always want to try to do is keep learning. If I had all the resources in the world, I'd be going to university all the time, right? And just learning new things.
Cool.
So, if you're in college, do whatever you can to get as many skills as you can, um, so that, yeah, you're just contributing and being able to grasp onto new lessons and that sort of stuff.
What do you think of the whole breadth versus depth kind of thinking? So should you go really deep in one thing or try lots of things, or where do you kind of sit on that? Is it lots of things or T-shaped or what kind of thing?
Yeah, so I think a combination of the two. I'd say, shallow ends, but then have a deeper section, right? Like being able to understand even just a tiny bit about something that's outside of your specialty will help you when you're working on a design or working on a product or whatever, because oh, I need to consider that someone from this department might want to do this, right? X,
Hmm.
Y, and Z. So uh, at least to have an awareness of other aspects.
Gotcha. And Tony, just changing the question a little bit, um, what advice do you have for someone at the beginning of their career?
Um, just explore and try different things along the same lines. Look for something you enjoy, and don't don't be afraid to kind of like venture out of like your path. Um, Especially if you're in engineering, I think labeling an engineer is the worst thing you can do. Um, I think it's just you're a person who solves problems, and those can be in many fields. It doesn't have to be into one. And explore that and find something you enjoy, and I think it'll be easier to make a career out of something you enjoy in the long run.
Oh yeah, great advice. Awesome. Thank you both.
Thank
Thank
you.
you.
All right. Bye, everyone. Thanks for listening to this conversation with Adrian and Tony. Thank you again to our founding sponsor, Open Robotics. See you next time.